When you click Submit on a web form, a data packet travels behind the scenes to instantly create a new record in a database. Today, we are going to build the pipeline that makes that happen. In the next few minutes, we'll build a functional Node.js backend from scratch, connect it to a local MongoDB database, and write a complete set of CRUD APIs to create, read, update, and delete data. To follow along, you need 3 tools installed: Node.js to run our server, MongoDB Compass to host our local database, and Postman to test our API routes. Connecting this specific stack gives you the infrastructure needed to move past static HTML pages and start building fully dynamic, data-driven applications. Let's start the clock. Step 1 is initializing our environment. In your terminal, run npm init to generate a package file, followed by npm install Express Mongoose. Express will handle our server routing, and Mongoose will bridge our server to the database. Inside your main file, mongoose.connect opens a direct line between our node server and database instance. Then app.useExpress.json acts as a middleware filter, intercepting and formatting incoming requests into clean JSON objects for our server. Next, we establish a schema. A database needs to know exactly what kind of information it is allowed to accept. We do this by creating a new user model file. Inside this file, we define our fields. We assign the name and email properties as strings. We set the age property as a number. Finally, we add a created@at property, formatted as a date, using date.now to automatically log the exact timestamp of creation. At the bottom of the file, we export this model using module.exports. This makes our precise data structure globally accessible to our main routing logic. By explicitly defining these rules up front, you create a strict blueprint. If a client submits an age as a word instead of a number, the schema rejects it, preventing malformed data from reaching your tables. Now we write the post endpoint to add a user. We set our route to /API/users. Because database operations take time, we make this an asynchronous function and wrap our logic in a try-catch block to handle any backend errors. Inside the try block, we call user.create, passing in the incoming request body. We use the await keyword to pause execution until MongoDB confirms the record is saved. Once successful, we send back a status code of 201. Let's look at our API testing interface to send our first request. In Postman, select the post method and enter your localhost URL. Then type out a raw JSON payload containing a name, email, and age. Hit send. Open up MongoDB Compass and click refresh. You will see your exact JSON payload sitting perfectly inside the new document collection. This single block of code takes a temporary network request and locks it into persistent storage. We have officially completed the create step in CRUD. To modify existing records, we build a put route. Unlike post, we append a dynamic parameter to the route URL, a variable representing the user's ID, so the database knows exactly which record to alter. Here is our database UI. Notice that MongoDB doesn't use simple numerical IDs like 1, 2, or 3. It assigns a complex auto-generated string called an object ID to every single document. Back in our code, we use rec.parameters.id to extract that string straight from the URL. We feed that ID, along with our updated request body, into the findById and update method to apply our changes. Grab an object ID from Compass, paste it into your Postman URL, and send a new age value through a put request. Refresh the database, and the age updates instantly without affecting the rest of the document. Deleting data requires the exact same targeting mechanism. We set up a delete route, grab the ID parameter from the URL, and use the findById and delete method to instruct MongoDB to wipe the entire object. Send the delete request through Postman using that same URL. When you check your local database UI, the target record is permanently gone. Relying on these unique object IDs ensures absolute precision. When managing databases with thousands of concurrent users, dynamic routing is the only reliable way to update or remove entries without breaking adjacent data. In just a few minutes, you've configured a local server, defined a strict data schema, and successfully executed complete CRUD operations. Postman allowed us to simulate network traffic, but it's ultimately just a stand-in. In a real project, you swap Postman out for your front-end interface, wiring these precise URL routes to the buttons and forms on your website. If you hit any errors or get a bad status code, check the exact syntax of your endpoints. The complete source code for this project is linked in the description below, so you can compare it against your own file. You now have a fully functional API. This backend is the silent engine that will process, validate, and store the data for any front-end application you build next.